Wow, you guys having a good morning? Yeah. Everybody have enough coffee? I'm still working on mine. It takes me a while. So excited to be here and really excited to get to be the first speaker of the day. Because I can show everybody else, how not to do it, maybe. We'll see how it goes. All right, looks like the clicker's working. That's me. Just a little bit about me. I have been, so I was a senior technical fellow at Lockheed Martin for about 25 years, so I've built lots of systems. And I'm currently at the Software Engineering Institute, where I get to work a lot with different space programs, kind of helping them to be digital, right? The goal is to get to Mars first, and so what does that mean? That we have to go a lot faster. So my talk is going to be about what the challenges in space are, and then potentially some ideas to help us do that, all right? So here are the challenges for space, and I bet you, as you look at these, you may say to yourself, I actually have these same challenges in my organization, all right? So everything that we build, or most things, typically has hardware, so we've got things like long lead times, very expensive test requirements, a lot of dependencies. Dependencies are the killer. Complex risk management. Now that we've connected everything, a very large attack surface. Safety and reliability concerns, and regulatory requirements. Has anybody had any of those challenges in your organization? I figured not as unique as you think. All right, long lead times. So really what we're looking at is we're building cyber-physical systems, and we have to bring together hardware and software. And as I mentioned earlier, I worked at Lockheed for a long time. And one of the things I found that is even if we got the software done really fast, it didn't get the system done any faster. The handoff between the hardware and the software is still killing us. So we actually have to optimize the entire life cycle, right? So the most common thing I hear is, well, Agile and DevOps are for software. You know what? Even ChatGPT says it. I was so sad. We have really expensive test requirements, and the reason that matters is because we want to test up front, we want to test first, and we want to test all the time. And typically, for a lot of these programs, one of the things that I run into is we haven't even purchased the test requirements, or the test environments yet. So we can't start. So it's a problem right out of the gate if we don't have the environments. So we really need to be able to make the case for our program managers, directors, executives to invest the money early so that we can build to the test, right? We can meet those test requirements first. Multiple dependencies. So when you take a look at this, right, a single satellite has some dependencies. Once we get to a constellation of satellites, there's even more dependencies. And we're constantly having to work together. We've got a lot of legacy systems up there in space. Then we're trying to put new things. They don't talk to each other, right? So we need to be able to visualize those. Very complex risk management. If I think of a GPS system, some things that can happen. Jamming. Jamming is a big problem. Spoofing, right? So there's a lot of cybersecurity concerns. Then you got weather, solar interference. So there's a whole lot of things that can happen here. We have a very extensive attack surface. I do not think that when we first started launching that we even considered the possibility of people hacking things in space. Now, last year at Black Hat, what did they present? How to hack the SAT. All right, so think about it. That would be really bad for anybody who's got any kind of navigation services, communication services, everything. So it's a scary thing, right? We need to make sure that we can look at this attack surface. Typically, we've got a lot of high-stakes safety and regulatory requirements. Now, we can't just get over those or get by those because we're Agile or DevOps, right? We have to build them into the cycle. And right now, a lot of them are actually aligned very much to a waterfall cycle. I read this fantastic paper out of Europe when they were talking about the European space standards, and what they were trying to see is, was there any conflict between Agile and meeting the European space standards? And I think out of 276 standards, there was only 16 that were in conflict. And you're like, hey, Robin, that's still a big deal. Like, we can't be in conflict. But when you looked a little further, the conflict came from the fact that the verification and validation was at a phase gate. It wasn't because it was an actual safety concern. It's because the concern, the validation occurred at a phase gate, and if you didn't have, let's say, a PDR, preliminary design review, CDR, big phase gate review, they couldn't do the validation. All right, so that says we have to update how we manage and validate safety in a different way. I won't go through all of these, but there's plenty of regulatory and compliance hurdles we have to look at. So I told you all the things that are wrong, all the things that are going to say, hey, I can't actually do Agile and DevOps for this. Well, I would disagree. Again, I've worked on everything from F-22 to the F-35 to Orion, and I can tell you that we absolutely can do Agile and DevOps to build cyber-physical systems. And by cyber-physical, what I mean is an aircraft or a spacecraft or an automotive vehicle, right? They're all cyber-physical. And so we recently published, me and a co-author, a book. And it's called Industrial DevOps. All right. I don't know if it was the best term. We started writing papers back in 2017, so it kind of stuck. But we put together about 9 principles to how to build large-scale, safety-critical, cyber-physical systems. And so I'm going to walk you through those. All right. And here's what I'm going to say. None of them, even though we're talking about space, are rocket science, all right? We are talking about pretty much the same thing. 1, organizing around value, right? How many of you guys have these stovepipes in your organization, right? I've got program management, then I've got systems engineering, I've got design, I've got software. And they're all focused on trying to optimize delivery, but optimize delivery within their particular silo, not optimize delivery for the system, right? And this is a real problem. Actually, I frequently tell people, wouldn't it be a great idea to have a small workshop building a CubeSat? Then the reason I say that is because it would take you 5 minutes to see the problem with the handoffs on something that small. But typically what we're looking at is very large programs. It's difficult to see how these handoffs are causing problems on things like the F-35, right? So they're so large. Multiple horizons of planning. All right, so many of you have done Agile and DevOps probably for years. How many people have 2-week sprints? 1-week sprints? I was getting overexcited. Well, here's one of the things we got to do. We still need a long-term plan, and so we call it multiple horizons of planning, right? I can't get to Mars in 2 weeks. So what I focus on is what I call empirical planning. And you can ask me what the difference between that is and predictive, which is, my integrated master schedule. And if you've ever seen an integrated master schedule, especially for a large-scale system, it will tell you what Robin is doing in 2028 on Thursday, in October, the last Thursday of the month. but we know that that's not real, all right? So what we need to do is connect the short-term plan to the long-term plan. And typically what I do for a large system is I might have a 5-year plan that breaks down into an annual plan, breaks down into a quarterly plan, breaks down into a sprint plan, and it breaks down into a daily plan. But I use empirical data from each of those plans to further inform, meaning if I deliver, I don't know, 5 tasks or, out of 10 every day for the sprint, then it's pretty likely I'm going to be about 50% complete, right? I planned it wrong. I'm going to use that to inform the sprint plan and say, hey, let's not take so much into the sprint. I can do the same thing for the 2-week plan and apply it to the quarter, and I can do the same thing for an annual plan. There's this thing that a lot of executives think is that we can just magically catch up. It's never the case. So there's a lot of data to link together the short-term plan to the long-term plan. Some of the really cool things that have happened is technology has improved exponentially, right? So in the past, those long lead times for the cyber-physical system, meaning I have to procure hardware before I can actually validate something on it, has reduced, right? I can take the physical system and put it into what I would call cyberspace, all right? So basically doing things like simulators and emulators. Yeah, we've had them for a long time, but they've gotten better, so I can get faster feedback. A digital shadow, right? So that allows me to do some simulations on the entire system. A digital twin gives me real-time telemetry both ways that allows me to make updates on the system in a safe space. Actually, I found when I was talking to Siemens Healthineers that they are building digital twins of humans and trying out new drugs and things on the digital twin there. I was like, oh, that hadn't even occurred to me. And then if I want to try out on low fidelity hardware, right, 3D printing or what we call additive manufacturing. So the ability to get the feedback that we were able to do within software, we're able to do in hardware systems too. It doesn't totally negate the need to do hardware test when we get all of the pieces together, but it does reduce our risk a lot. We have to architect for change and speed, and there's nothing new here, but for some reason we still struggle with it. You need a modular architecture that has really defined interfaces, right? Both within the software and the hardware. This allows me to make updates quicker, and it allows me to validate things faster. Now, the downside is we still have very monolithic systems, meaning everything's kind of coupled together. Interesting thing, when I was at Lockheed, we hired mechanical engineers, aerospace engineers, all kinds of different engineers. And the first thing that they do when they come is they start coding. I can tell you, you can really see the difference between somebody who's been trained as a software engineer and their code, and somebody who has been a technical person, what could go wrong, and their code, right? It's just big monolith junk, like it's so bad. So it doesn't shock me why we have so many monoliths out there. And for the longest time, people would tell me, Robin, it's just software. I was like, oh. So yes, both for the hardware and the software, modular architecture. Now, am I going to say microservices for everything? No. Context matters, right? Real-time embedded systems have timing constraints, etc. Basically, I need to make the decision. I have to think about it. All right, iterate and manage queues. I got an opportunity to work with a small business last year. It was really cool. Orbit Fab. Orbit Fab is building gas stations in space. And just so you know, they do both hardware and software. And we decided, so that they could learn the fastest, we put them on 1-week sprints. So everybody who tells me that hardware needs 4 weeks or 8 weeks, not so much. Actually, they were doing really well on the 1-week sprints. And they even had the opportunity to, refuel the International Space Station. So great job. Now, what do I mean by that? It doesn't mean that everything that's coming out of that 1-week sprint was deployable, right? It means that it was something I could learn from, I could validate. So it could be updates to models. It could be updates to simulations. It could be machining. They even had some machining on there, right? So we're still doing that kind of plan, do, check, act loop, but treating work as work, right? It doesn't just have to be software work or systems work. All work that I need to put together this system. Cadence and synchronization. This is also key when I have a number of teams. When I had my first Agile project, it was in 2002, and it's not because Lockheed is bleeding edge by any stretch. It's because we had a customer who gave us an RFP, and we said, yeah, we'll do that. So it was pretty early, and I was like, oh, I want all teams to be autonomous, and they can do, their own schedules, etc. However, that's very difficult if you need an entire system to come together, right? So as we scale, we reduce some of the autonomy. Totally get it. Doesn't mean we can't be agile, but we do have to look at, integration points. So we want to make sure that we have cadence and synchronization at the same time. The book I would recommend reading is Principles of Product Development Flow by Don Reinertsen. Because one of the things that he recommends is that for manufacturing in lean, we want to remove all variability from the system. But in product development, we want to remove all bad variability, and we want to exploit good variability as innovation. To do that, we have to take all of the noise out of the system, right? So this cadence and synchronization also does that. It allows me to remove yet another variable because I can count on those. We want to integrate early and often, and this comes back to, especially for hardware, that I invest in those test environments early and I automate, right? They're like, oh, you can do that for software. No, we can actually do that for the entire system. Now, fortunate or unfortunate, the Air Force was going on tours of SpaceX, I want to say in 2017, 2018, and one of the things that they did, which was really not a positive at the time, is they brought out a couple of junior engineers who had actually had the opportunity for their first couple years to work at Lockheed, and now they were at SpaceX. And what they said is, at Lockheed, we had never deployed once. And at SpaceX, we deploy to the test environment, right, that has hardware in the loop and software in the loop every day. I was like, oh, that really hurts. Again, because the way that SpaceX decided to build their systems looks a whole lot like software. And I think it's because they were digital natives, right? And Lockheed Martin was very successful for the last couple of decades, building a certain way. So they didn't change the way they built, right? And we actually have to, all right? So really looking at things like putting together a DevOps pipeline for the entire system. Shift left. All right, so I say begin with the constraint all the time. And what you see here is McLaren's digital twin. One of the things they're able to do is to begin with test, right? And they can make small modifications. See a lot of this in automotive. Actually had the opportunity to talk to an engineer at NASCAR, and he said, because what you're going to hear is digital twins are expensive, and they are, right? They're an investment. But one of the things for NASCAR that they have to do is they've got to crash the vehicle so that they can find all of the spots that are weak, right, and fix them and make them stronger. They also impact the actual track. And they said typically to crash a vehicle on purpose costs them, a couple $1 million. But they can do the same simulation in their digital twin. They've got a digital twin of the track as well as the vehicles, and it costs them about $100,000. So they can keep doing it, right? It's still not free, but it's exponentially cheaper than doing it in hardware. And so again, we want to begin with the constraint. How do I test this early? The last one that I want to tell you about is the growth mindset. And this is a really tough one because we don't necessarily want to fail. Now here, again, example, SpaceX, a crash, it totally, from everybody else's point of view, probably looked like a failure. But Elon had posted shortly after, hey, RUD, rapid unscheduled disassembly, i.e. blew up. We got all of the data we needed. That's a huge mindset change. Now, I can show you, I have other data that would back this up, that NASA, and the large contractors, so Boeing or Lockheed, did the majority of the launches 20 years ago, right? And SpaceX maybe did one. Over the years, they've decreased the cost to launch so much that now if I have a satellite I want to get into space, even if I'm at Lockheed, even if I'm at Boeing, I'm piggybacking on SpaceX. It's cheaper for me to piggyback on their buses than it is for me to do it, right? Because they've learned so much. But they had to take some failures there. This is one thing we have to do. Now, at Lockheed, I would tell people, hey, I don't want to have the failure when the pilot's in the cockpit, right? I don't want the F-22 to fail. But I'm totally fine with failing in simulators and validating things early, right? So we got this impression that we can't fail anything. Well, if we can't, then we're not learning anything either, right? It means we're never trying something new, extending this. The only way you can ensure that you never fail. So really looking at the way that we take in new information, even things that we're pretty sure we've known for years. One other quick story. So a few years ago, Team Topologies came out. Did anybody read that book? It's a great book. But the first time I read it, I was so annoyed. I was not happy. I had just spent the last 2 decades really pushing a rock uphill at Lockheed Martin, telling them we needed cross-functional teams, value stream working together, right? I knew what I knew. And then I got this new idea. I was like, oh. But then I thought about it. Oh, platform team, that makes a good sense. That's pretty good. Complex subsystem, guidance, navigation, and control, that's pretty independent. They brought new information that didn't align with my mental model immediately, which happens to everybody, and I had to step back and learn, right? Realize that everything's changing. I'm getting new information all the time. So even I, who I would say a proclaimed Agilist for the last however many years, has to step back and remember new information, I need to grow, right? So that's the growth mindset. So we've written a lot of papers. IT Revolution is a company owned by Gene Kim. He wrote the Phoenix Project, and he's published a number of our papers over the last 7, 8, 9 years. And they're also the publisher of our book. And if you take a picture of this QR code, you can get the first chapter for free. And I'd be really interested in any feedback. If you do get it and you reach out to me on LinkedIn and you have feedback, I'll actually send you a digital code to get the whole book online for free. The goal here, let me get rid of this. You see this? Oh, dismiss. The goal for me was to make an impact, right? I really want to see us be able to build large-scale safety-critical systems at what I call the speed of relevance. And the speed of relevance varies, right? So Netflix, I may need changes every second, every day, whatever that is. If I am making an over-the-air update to a large surface ship, every 3 or 6 months might be relevant for them, right? Because I don't want to train my entire crew on something different. So speed of relevance is critical. And with that, I think I have a few minutes for questions. Do we have any questions? Or I just stun you, or you didn't have enough coffee yet? You can go either way. Yeah? I don't have a microphone. Can we get a microphone? That's still pretty hard.
1, 2, and 2. And 2.
See, I'm testing the pipeline. All future speakers, they'll already have this. This is one step at a time.
1, 2, 1, 2. Oh, it's working. Okay. So the question I have is about uncertainty because, well, I understand that in aerospace, you have to have all the interface contracts very well defined between the software, the hardware, everything. But in every single project that I worked at, you can plan as much as you want. When you start coding it, or you start, I don't know, just talking to people, you're going to say, oh, no, it doesn't work like that. So how can you, is it even possible to remove uncertainty from the pipeline?
Absolutely not. It's not possible to remove uncertainty, which is why when we come into that multiple horizons of planning, on a regular cadence, we have to go review the plan, because, yeah, there's no way. One of the things that I found very interesting, got to talk to Joe Justice, if you guys have ever chatted with him, and he was at Tesla for a long time. And one of the things they do with Tesla, apparently, is they update even the hardware manufacturing while manufacturing. And they use very much like a software approach, which is they branch out, they try a new fuel pump, they validate whether that fuel pump's better than the existing one they're currently putting in the cars. And if it is, they merge that branch back in. So he's making changes even on the manufacturing floor. Like I said, I would have never thought that just a couple of years ago. All the time, because we have to be able to adapt. There's no way to remove uncertainty. And the larger the system, the more complex, the more likely you've got emergent behavior, which is causing even more uncertainty.
Thank you.
Mm-hmm. Oop, one more, two more.
Here we go.
I'm a tester all day.
Thanks. So, simple question. You mentioned there at some point, you grabbed some company and you were doing consulting for them, and you put them on single-week sprints so they could iterate faster. My experience is when I'm doing sprints, it's both too fast and too slow. Because if I have to pivot on something because something's not working, 1 week is still too long. If I figure out on Monday something's not working, I don't want to work to wait until next Monday to change. Do you have an idea on how to go even faster? Because
yes, actually. So we had a contract with, when I was at Lockheed, Department of Homeland Security, so DHS. And DHS wanted, now this was software specific, so it was fine, but they wanted to have a proposal where we could complete an entire application. They wanted to prove it within 1 week. And I had developers in Brussels, I had a tester in Texas, I had some folks in Minnesota. And so we were on 4-hour sprints, and we would demonstrate to the executives every 4 hours the update to the application. This sounds bad, but I was like, if the executives, because it had to be usable, right? So that was one of the criteria. And I figured if they could use it, anybody could. So yeah, I know that's bad. This is long-term career isn't going to work for me. I think I am all done, but thank you guys for giving me the opportunity to be your first speaker of the day.